In this lesson, I'm going to discuss the squeeze theorem, one important theorem on limits of functions. This is differential calculus. I'm Romel L. Marquez, sharing with you this video lecture. What is squeeze theorem? Squeeze theorem is stated as follows. Let f, g, and h be functions defined on some open interval I containing a except possibly at A itself. And let g of x be inclusively between f of x and h of x. For all x in I, for which x is not equal to a, if the limit of f of x as x approaches a and the limit of h of x as x approaches a both exist and are equal to L, then the limit of g of x as x approaches a exists and is equal to L. The squeeze theorem is sometimes called the pinch or the sandwich theorem. Let us illustrate this squeeze theorem graphically. Y-axis, x-axis. Let's say x equals a is here, contained in the interval I, and let's say along the y we have L here. At x equals a, the functions f, g, and h are not necessarily defined. The graph of f is this. So let's call this f. The graph of h is given by this. So this is h. And then finally, the graph of g so this is g. In this illustration, if g of x is squeezed between f of x and h of x near x equals a, and if f of x and h of x have the same limit L, as x approaches a, then g of x is forced to have the same limit L as x approaches a. To further understand the squeeze theorem, let us have the following examples. Number 1. If 4x minus 9 is less than or equal to g of x, and g of x is less than or equal to x squared minus 4x plus 7 for x less greater than or equal to 0, find the limit of g of x as x approaches 4. Solution. Let f of x be equal to 4x minus 9 and h of x is equal to x squared minus 4x plus 7. Let's take the limit of f of x and h of x as x approaches 4. Limit of f of x as x approaches 4 is equal to 4 times 4 minus 9, and this is equal to 7. For the limit of h of x, h of x is x squared minus 4x plus 7. As x approaches 4, is equal to 4 squared minus 4 times 4 plus 7, and this is equal to 7 also. Hence, by squeeze theorem, the limit of g of x as x approaches 4 is also 7. So let us have number 2. If 2x plus x squared is less than or equal to g of x plus x squared, and this is less than or equal to x to the fourth plus 2, for all x, find the limit of g of x as x approaches 1. Solution. First, let us manipulate 2x plus x squared less than or equal to g of x plus x squared less than x to the fourth plus 2, so that the middle of this continued inequality is simply g of x. We can add on its part negative x squared, getting 2x less than or equal to g of x, and that is less than or equal to x to the fourth plus 2 plus 2 plus negative x squared. Here, f of x is equal to 2x, and h of x is equal to x to the fourth minus x squared plus 2. Let's take the limit of f of x as x approaches 1. F of x is equal to 2x. 2 times 1, so that is equal to 2. Hence, the limit of 2x as x approaches 1 is equal to 2. For the limit of h of x to the fourth minus x squared plus 2, as x approaches 1, this is equal to 1 to the fourth minus 1 squared plus 2. Simplifying, this gives us 2. Since both the limit of f of x and h of x as x approaches 1 are equal to 2, then by squeeze theorem, we can conclude that the limit of g of x as x approaches 1 is also equal to 2. Number 3. the absolute value of g of x minus 3 is less than or equal to 4 times x plus 2 quantity squared for all x. Find the limit of g of x as x approaches negative 2. Solution. Given the absolute value of g of x minus 3 less than or equal to 4 times x plus 2 quantity squared. This inequality is equal to the inequality negative 4 x plus 2 quantity squared is less than or equal to g of x minus 4, minus 3, less than or equal to 4 times x plus 2 quantity squared. Let's manipulate that continued inequality so that the middle part is simply g of x. Hence, we have negative 4 times x plus 2 quantity squared plus 3 less than or equal to g of x, and that is less than or equal to 4 times x plus 2 quantity squared plus 3. Here, our f of x is equal to negative 4 x plus 2 quantity squared plus 3, while g of x, h of x, is equal to 4 times x plus 2 quantity squared plus 3. Taking the limit of f of x as x approaches negative 2, we get negative 4 times negative 2 plus 2 quantity squared plus 3, and this is equal to 0 plus 3, and that is equal to 3. Taking the limit of h of x, that is 4 x plus 2 quantity squared plus 3, as x approaches negative 2, we get 4 times negative 2 plus 2 quantity squared plus 3, and this is equal to 0 plus 3, and finally we have 3. Since the limit of f of x and h of x as x approaches negative 2 both exist and are equal to 3, then by squeeze theorem, we can conclude that the limit of g of x as x approaches negative 2 is equal to 3. So let's proceed to example 4. Use squeeze theorem to evaluate the limit of x to the fourth as x approaches 0. So x to the fourth times cosine of 2 over x as x approaches 0. Solution. The limit of x to the fourth as x approaches 0 is equal to 0. The limit as x approaches 0 of cosine 2 over x if x approaches 0, 2 over x becoming infinite. From the left, it is becoming negative infinity, the limit. From the right, it is becoming positive infinity. As 2 over x gets bigger and bigger, its cosine oscillates between negative 1 and 1. Hence, the limit of cosine 2 over x does not exist. And here, we cannot apply directly limit of product as product of limits. So we cannot apply that rule. So, but in trigonometry, cosine 2 over x is always between negative 1 and 1 inclusively. If I'm going to multiply this by x to the fourth each side, then I will get negative x to the fourth less than or equal to x to the fourth times cosine of 2 over x, and that is less than or equal to x to the fourth. So from here, I can take f of x as negative x to the fourth and my h of x as x to the fourth. Let's take the limit of f of x and h of x independently. So x approaches 0. The limit of negative x to the fourth as x approaches 0 is equal to negative 0 to the fourth, and that is equal to 0. Limit as x approaches 0 of x to the fourth, and that is also equal to 0. since the limit of f of x and h of x as x approaches 0 both exist and are equal to 0, then by squeeze theorem, we can conclude that the limit of g of x is also equal to 0. Limit, and our g of x is x to the fourth cosine of 2 over x. So the limit of x to the fourth times cosine of 2 over x as x approaches 0 is equal to 0. Okay. Let us have number 5. If 2 times x minus pi quantity squared is less than or equal to x minus pi quantity squared times g of x is less than or equal to 2 times sine squared of x um, for all x evaluate limit of g of x as x approaches pi. Solution. We're given 2 x minus pi quantity squared is less than or equal to x minus pi quantity squared g of x, and that is less than or equal to 2 sine squared x. So here we need to express the middle part in terms of just g of x. So let's divide this continued inequality by x minus pi quantity squared, getting 2 less than or equal to g of x, and then less than or equal to 2 sine squared of x over x minus pi quantity squared, since in this limit we're just interested to values of x that is close to pi but not equal to pi. So for x not equal to pi. So here we can take f of x to be equal to 2 and h of x to be equal to 2 sine squared of x over x minus pi quantity squared. Let's take the limit of f of x as x approaches pi. Since f of x is constant, so the limit is also 2. And for the limit as x approaches pi of h of x, that is 2 sine squared x over x minus pi quantity squared. The limit of the denominator as x approaches pi is 0. The limit of the numerator as x approaches pi is also 0. Hence, this is of indeterminate form 0 over 0. Let's try if we can apply this theorem. Limit as x approaches 0 of sine x over x is equal to 1. From trigonometry, sine of x is equal to negative sine of x minus pi. Let's check. Sine of x minus pi is sine of difference, that is equal to sine of x cosine pi, but cosine pi is negative 1. So it means it is negative sine x times negative, so it is positive sine x. Then minus cosine x times sine pi, but sine pi is 0. So that term vanishes. So getting negative of sine of x minus pi is equal to sine x. Okay? So sine x is equal to negative sine of x minus pi. So therefore, limit as x approaches pi of 2 times sine squared x all over x minus pi quantity squared I can rewrite this as limit of 2 times sine of x minus pi quantity squared. Negative is not necessary anymore since it is being squared. All over x minus pi quantity squared. And this is equal to as x approaches pi. So this is equal to limit of 2 as x approaches pi times limit as x approaches pi of sine of x minus pi over x minus pi quantity squared. Let's move a little here. As x approaches pi, x minus pi approaches 0. Hence, we can write this as limit of 2 as x approaches pi times limit as x up minus pi approaches 0 of sine of x minus pi over x minus pi, and then we square this limit. Okay? So this is equal to 2, and the limit of this is equal to 1. It satisfies now the theorem limit of sine x as over x as x approaches 0 is equal to 1. Finally, we get limit which is equal to 2. Since the limit of f of x as x approaches pi and the limit of h of x as x approaches pi both exist and are equal to 2, so by squeeze theorem, we say that the limit of g of x as x approaches pi is also equal to 2.